Rightio. So we've now got a lovely dial here. You know, remember, don't get hung up. Just because you've got wedges and things like that, I've never seen anything like that before. Just think it's just a dial, yeah? What type of alcohol is that? That's a primary alcohol. That is a secondary. No, it's a secondary alcohol. Yeah, secondary. Yeah. Okay, so excess dichromate and sulfuric acid I'm refluxing. So what am I going to make? Well, if I've got a primary alcohol there, if I just, you know, don't lose your stereochemistry when you do this. So you're going to end up with a carboxylic acid appearing off of this carbon, and then that boy is going to become a ketone, like so. And then the next one, to get from him down to where you change that ketone that I had here onto an alcohol. You're right, I'd use sodium borohydride.
Why is the carboxylic acid not hydrogen?
Right, so this is from, well, this is from A2 and AS3. What would you observe? You're using potassium dichromate, it goes orange to green. If it was reflux, if compound E was heated under reflux with excess, why were these conditions used? Well, if you didn't reflux it, you would have made the aldehyde instead of the carboxylic acid. The type of reaction taking place is actually nucleophilic addition, but you could have had reduction if you wanted, or you could have had reflux as well. A chemical test that you can use to detect a carbonyl group, you know this one, 2,4-dinitrophenohydrazine, and you see an orange precipitate. So that, 1, 2, 3, 4, 5 marks, easy peasy. Compound E is a single stereoisomer. Draw another one, state the type of stereo. So I'm going to go back to compound E. So just, you know, okay, well, first of all, what type of stereoisomerism is it going to be? Can it be cis-trans isomerism? No, because it hasn't got a double bond. So all you're going to do, just copy it out. You've just got to change one of the bonds. So the way I would do it is I would just change that into going that way, like so. So you just change that into a wedge, into a dash going back. So now I've got my methyl group. This is a methyl group. So now I've got my methyl group going into the board, like so, rather than sticking out. And that's what I'm saying. Okay, so you did it right. I can't. 4.56 divided by 160. That equals apparently 0.0285. You then need to work out how many, you can do it this way, you can work out how many moles of, so that was E, how many moles of G did you form? It's 3.15 divided by the molar mass of G, which is actually 174, and if you do that, that comes to 0.0181. Then it's that number over that number times 100, and you should have got 63.5%. Oh, right, so this is an interesting one. I got compound G, heating it under reflux, presence of concentrated sulfuric acid, an ester and a small inorganic molecule are formed, complete the equation, and they've drawn it to you like a gift, haven't they, really? They've got the carboxylic acid here and the alcohol here, so you're just going to draw yourself. We did a question like this, didn't we?
I didn't think it could be in a round circle, just loop stuff off.
So it just loops like that, plus H.
No, it's a pentagon.
Oh yeah, I'll put an extra carbon. Okay, put an extra carbon. And plus H2O. So you just loop it round. So if in doubt, you know, just do it on and just go, oh, okay, so that's just going to go there, that's going to go, that's not, there's your answer. Okay, so question 5. It gives me the carbon and hydrogen elemental analysis, and it wants me to show that that's a molecular formula. So the first, well, you just do it the normal way. Carbon, hydrogen, oxygen, 73.15, 7.37 for hydrogen. That leaves you oxygen being 19.48. you divide that by 12, that by 1, that by 16. I think that becomes 6.10, 7.37, 1.22. Divide by the smallest one, which is that one. That gives you 1 to 6 to 5. So your empirical formula is C5H6O. If you add all of those up, so show it, 5 times 12 plus 6 plus 16, that should give you half of the molecular mass, so that's 82.
Yeah.
So that comes to 82. Oh yes, and therefore, because it's 164 is equal to 82 times 2. You know, spell it out for them, and therefore it must be that. So this is your structure one at the end. First of all, how many different carbon environments are you? Easy one. You count your peaks, and you find you've got 7 peaks. So therefore, there are 7 environments there.
I thought that was a trick question.
Yeah, I know. I was like, there's got to be more to this than that.
Hydrogen NMR there. Then it says, why do we use TMS? TMS is used as a reference for the NMR spectrum, so it's a standard that we use. What information can be used by the integration chain? It's the relative number of hydrogens in each environment. So that's the one for that one. And then finally, what is the structure? So you know you have got, first of all, 7 carbon environments. What's this boy here? That is going to be your benzene ring. How many hydrogens, based on this, must you have in your benzene ring? You've got to have 5 hydrogens. So you know you've got a benzene ring with 5 hydrogens coming off. You also know from this peak here, you have got a CO group there, like so. So you know you've got that. At the moment, we also know we've got a benzene ring with just one substituted hydrogen on it as well. If you have a look here, your hydrogen NMR gives you some key information. You've got 6 hydrogens in the same environment that are split into a doubler. So 6 hydrogens, what's that going to tell you? You've got two CH3 groups. So, and what's in between them? What must they have in between them?
A CH. Okay, so she is a doublet.
So there you go. That's your molecule. So then you just go through the motions of assigning your peaks on your carbon NMR, explaining your splitting patterns, the fact that you've got...
I think you might have the...
oh, have I put it the wrong way around?
Yeah,
Oh,
I'm pretty sure it's the benzene to the oxygen to the...
oh yeah, sorry. Okay. So it actually is... How did I work that one out? Amina, how did you work that one out? It's actually that one. So then you go back.
Oh, it showed that CH is next to there was only 1 hydrogen in the environment, but it's C double bond.
Yeah. So you can work out from your chemical shifts that that carbon must be attached to that oxygen there. So you've got that one.